Attic PC guy here. I thought you guys could use a break from all the unboxing and upgrade related videos that I've been doing lately. And I thought I would pick up on a series that I left unfinished a while back, which was in relation to upgrading your PC's capabilities without actually upgrading the hardware via overclocking. Now, back then I did a very basic video about overclocking your graphics card or GPU, and my intention was to do that video that included not touching any of the power settings and not increasing the voltage or anything of the sort, and then doing a bit more of a more in-depth version of that with those more advanced settings at a later date. However, I've found out that my GPU is voltage locked. I cannot alter the voltage, it's a default setting, and while I could fix that by flushing it custom BIOS, to actually get around those settings. I decided not to because I don't want to upgrade right now, and there is always a risk when doing that your graphics card will be bricked. So I decided not to do that and scrap that idea, and I will do that video later on when I upgrade my graphics card. And for now I will be focusing on CPU overclocking, which I just did on my new setup. The videos are not all up yet, so the videos will be up later of me upgrading the rest of my setup, but it is already running, it's up, and I have it overclocked a little bit, and I thought it would be a good opportunity, since I just did all the research I needed to do on the subject, to do my own overclocking, to do a video about CPU overclocking, the basics of it. I will not go in depth on every tiny little setting. I also do not have a capture card for taping the BIOS modifications processes, but I will give you guys an overview, and you can pretty much learn a bit about what it is, what it involves, what are the risks and benefits, and all that sort of stuff. Now, to start up with, there is a kind of a popular opinion, I guess, going on amongst people that are not really used to overclocking and the sort, that it will probably kill your hardware, and that it's a very difficult thing to do, and that the tiniest mistake will pretty much destroy your computer. Now, while there is always a risk of that happening, not gonna lie, it can very well happen that you burn out your CPU while overclocking. If you play it safe and if you do some research on what you're doing, you don't even need a ton of experience. You just need to do your research properly. Uh, you will most likely be fine. There are safeguards in place on most motherboards. And it's very, very difficult to do a mistake that is not fixable while overclocking. Now, with that said, you can damage your CPU, I mean, over time, by inputting the wrong settings. But again, it comes down to research. So what is overclocking? To start with, uh, most PC components run on an internal clock. That clock is basically what keeps the instructions and the processes and everything synchronized with each other, so that everything works nice and smoothly. Now, the best analogy that I can make to overclocking as in a real life thing is, you have 10 seconds, you can say X amount of words in 10 seconds, and that is how efficiently you can use your time in those 10 seconds. Now, overclocking is basically saying to the CPU, you have 10 seconds, but those seconds are now actually 20, or those sections are actually now 15. So you're basically making the clock go faster. Imagine that you could, so to speak, speed up the clock uh, in real life, and you could do the same amount of work that you do in one day. You could do it in half a day, but it would still be one day, but the work would just be done in half a time. That's basically an analogy to overclocking. It's the difficult thing to come up with an analogy like that, but let's say that I am saying this amount of words in 5 seconds.
And let's say that I am now saying this amount of words in 10 seconds, and as you can see, it goes a lot faster, but it takes around the same amount of time.
So that is basically the basic idea of overclocking for someone who has no. Well, it's probably not very clear, but bear with me. Anyway, um, what are the advantages of overclocking? You ask. Well, first of all, when parts are shipped out of factory, they are shipped out at a level that is guaranteed to work, and the way that manufacturers do that is that they basically they do not guarantee everything to work to its full capability, because what that means is that any products that would be below full capability, they would have to deal with returns and warranties and stuff like that. So what they do is, okay, maybe your processor can run at 5 gigahertz all core, but there might be other processors that can't of the same product, because, and this is something that you might have heard me mention earlier in other videos, because of the so-called silicon lottery. This applies to processors, RAM, graphics cards, everything. As a very basic explanation, when these parts are manufactured, there are slight tiny imperfections in each chip that they are just physical imperfections, like from the quality of the silicon used, or the tiny little imperfections from air bubble. You take your pick. There are a lot of different possibilities, but all these tiny little imperfections affect how well the part will perform. Now, if it performs too bad, it will just be scrapped at factory. But if it performs to the minimum standard, it will just be shipped. And of course, you'll have the absolutely perfect chips that will overclock at, like, say, 5.4 gigahertz. And you will have also the less perfect chips that will barely overclock at all, no matter how hard you try. And they still fall within the minimum specification, but they just lost the silicon lottery. That's basically what it means. Now, what else can we say about overclocking? Those are the advantages are that you can basically get free processing power that you would otherwise not have without an extra cost. That's a pretty compelling argument, I would say, but you also have to keep in mind that there will be disadvantages involved. And also another advantage is that your processor will last you longer. If you would have a processor today, and okay, in 5 years, you're like, oh, it's starting to be, not enough and all that. Maybe if you overclock it a little bit, it will get a little bit faster, and you'll be satisfied with it for 6 or 7 years in place of 5. So there are those advantages as well. Now, the disadvantages are that it will shave off some life, or might, I could say, shave off some life off your part. And I'm saying this more to processors, but it applies to everything as usual. When you overclock, there are side effects that happen. And mostly to overclock, you will need to increase the voltage to your CPU, and that will make it generate more heat. Now, and those are the top two factors in degrading a CPU over time, heat and voltage. Now, voltage and heat will degrade the CPU over time. There are safe limits, which I will mention in a little bit, but as a overall explanation, let's say that your CPU would last normally at stock conditions. It could very well last 10 to 15 years, and in place of 10 to 15 years, maybe it will just last, 7 to 10. But what you need to ask is, you need to ask yourself, as someone who is looking into overclocking, you're probably kind of a beginner or intermediate PC enthusiast, and you probably would want to upgrade at any case, because it would just not fill your needs anymore after 7 to 10 years. So does it really matter that it will degrade a little bit over time? Probably not, because we're talking about 7 to 10 years and you might want to upgrade anyway. Also, it is easy to minimize its degradation or eliminate it altogether by staying within some safe limits to overclocking, as such as not letting your temperatures be too high too often. Any temperature over 80 degrees is crazy to keep it on a regular basis. And personally, and this might be a bit conservative of me, I try to keep my temperatures lower than 60, 70, but then again I am on water cooling, so that helps minimize degradation over time, as well as the voltage. I do not go crazy on my overclocks. I have it right now set at 1.29 or 1.30 volts on my CPU, and the safe limit for 24/7 usage is usually regarded to be somewhere between 135 and 1.4 volts on your CPU. So I am well below that threshold, so I am not too worried about degradation in the long term right now. So, that's fine. Now, what is this degradation that I'm talking about, really? It means that your overclock will not be stable at the voltage that you've given it. So it will need more voltage to keep the same clock going, or you will need to lower the overclock that you've done to keep it at the same voltage. So it boils down to it won't perform as well as it should. Now, those are the main signs of it, and obviously for voltage, that is kind of what I have to say on that term. For heat, you definitely need a better cooling system if you're going to overclock. Do not rely on the coolers that come included on your CPU, like the stock coolers from Intel and AMD. Do not rely on those if you're going to overclock, because even at stock settings, they are kind of lackluster. And if you're going to be pushing the heat even harder, then they are not going to be able to cope. So I'm not saying that you need to go full on water cooling loop and all that, or even an IO cooler, but a good a good air cooler will definitely be advised if you are going to overclock, at least. So, but that will be enough, and you don't need to spend hundreds on a cooler either. GPU cooler is mostly safe. You could basically set up all the settings to the max, and nothing would happen in terms of actually damaging your GPU, because it's all very controlled in the operating software from the graphics card, and it will not, no matter how hard you try, unless you flash a custom BIOS in there, it's not going to let you bypass those safeguards and do something that would damage it permanently. So you are very safe when overclocking your GPU, but on the CPU it is a bit different. Some motherboards have safeguards on them that will not let you push it too hard to destroy it immediately, although the degradation danger is still there, and there are not many safeguards against that, because that is a very personalized experience. And what is a good overclock for me might not be a good overclock for you because of the silicon lottery that I earlier mentioned. And I could perhaps run 5.2 gigahertz at 1.35 volts, but you might need 1.4 or 1.45. So there is no real way to make a uniform safeguard for every single processor chip out there. So it's kind of a it has safeguards that won't let you kill your CPU immediately unless you try very hard. There are power limits in place in the BIOS that you will need to change when you are going to overclock. And if you change them too much, that's what you could kill them. But then that boils down again to the research factor that I mentioned. Now, the settings that are the most dangerous there are power limit and core voltage. Now, core voltage, like I said, 1.35 to 1.4 are the safe for an everyday use. I would try to stay around that amount. There are other important settings like power, load light calibration, because of one factor is if you are feeding your CPU, let's say 1.3 volts, you might, on a monitoring program, you might see that it is actually on receiving, like, let's say 1.28 in place of the 1.3. That is something called droop, and the droop is basically voltage that never really makes it from the supply to the CPU because of physical resistance, electrical resistance along the way. Energy just gets lost, let's say. Load light calibration is a setting that allows you to basically account for that and kind of counteract that so that your CPU will actually get the voltage that you set it to. That's a bit of a more in-depth thing. I might do a video in it later when I find a way to record my BIOS. I'm just saying that it's out there. Let's see, what else can I... Other basic settings in the BIOS that you might need to mess with is to sync all cores so that all cores will be at the same frequency. That means that, for example, my 9700K, it boosts one core to 5 gigahertz, was it, or 4.9, but if two cores are engaged in turbo mode, it will be lower, and if all cores are engaged, it will be even lower. What happens when you sync all cores is that all 5 cores will boost to the same amount, which in my case, I have it at 5.1 right now, so they all will boost to 5.1. Other thing that you need to be aware of is something called AVX offset. Now, this happens because some programs utilize a set of instructions that they give to the CPU called AVX instruction set, and that is an instruction set that is a lot more power hungry and generates a lot more heat than normal processing instruction sets. What happens is that if you have a very high overclock and then you throw AVX instructions on top of it, and you have no choice because that's what the programs use. If they use it, they use it. Then your temperatures will rocket sky high and your PC will draw a lot more power than you want it to. So AVX offset is basically a setting that you can give to your motherboard that if there are AVX instructions being given, it will lower the clock by X amount. And this X amount is usually 100, 200 or 300 megahertz. You can set it up as you prefer. And what does it mean? It means that if you're not using AVX using programs, your overclock in my case will be at 5.1 gigahertz. If a program starts using AVX instructions all of a sudden, the clock will drop down to whatever offset you used in an effort to lower the temperatures and keep it from growing sky high with those instructions being utilized. Now, it's up to you if you want to enable this or not, depends on your cooling solution and how confident you are that it can keep up. I have it on more of a safeguard, but what this means is that you can have your full-on overclock most of the time because not many programs utilize AVX. And when they do, at least it will, sort itself out and you don't have to worry about the temperatures bumping up like crazy while they do it. Now, let's say the heart of overclocking will be the core ratio. What this means is that, for example, the base clock is 100 megahertz. If your stock CPU is at 4.6 or 4.8, I think, whatever it is, I keep forgetting. I'm sorry. I don't have a script, as you might have noticed, so I'm just kind of going with the flow. That's why I ramble a lot, and that's why I might miss some facts and go back and forth in the order that things should be. It's something I'll try to improve in the future, but I'm an amateur. I'm not a professional. I'm not a professional YouTuber that has everything pitch perfect, as you might have noticed. I'm just winging it. What was I saying again? Oh yeah, the base clock. So if your base clock is 100 megahertz, your CPU is 4.8 gigahertz. That means that you have a multiplier of 48. So it's the 100 times the 48 gives you your CPU frequency. Now overclocking basically means bumping up that multiplier. So instead of the 48 you type there 51, you will have 5.1 gigahertz. It's that simple. It just needs to have enough voltage to keep up. Right now, like I said, I'm running 5.1 gigahertz with AVX offset of 1. That means 5 gigahertz when there's AVX, and I'm running it at 1.29 volts. I might try to increase that in the future, but right now that's what it is. Again, Silicon Lottery, just because I'm using it like that doesn't mean that you will be able to. And again, there are a few more tiny settings that need to be set on the BIOS to optimize it a bit. Um, I have to confess that I have forgotten some of them. Um, I would advise to look for a guide for your specific CPU and your specific motherboard. Not necessarily a guide, but maybe people that share their experiences and that can give you some room where to start. Now, again, just because it did not work, it worked for them does not mean it will work for you. So what do you need to do once you actually have your overclock set on your motherboard? And again, research, research, research. Don't use the settings I gave you. Don't use the settings that someone else gave you. Look for what most people are using. Look for a couple of examples. Try to find a safe spot and start low. Don't immediately start at the 5.2 mark. Start at the 5 gigahertz. See how far you go. See if you can get it stable at the 5 gigahertz, and if you can, and if the voltage is not very high, and again, try to keep it under 135, 1.4. If it's not very high, if you're not there at the voltage yet, bump it to 5.1. See if you can get it stable there. How do you get it stable, you might ask? And this is getting to be a long video, but I'm sorry, there's a lot of information and I'm a known rambler. How do you get it stable? First of all, you see if it boots. That's simple. If it doesn't boot, it's not stable. Yeah. Then, as you boot it, you go into Windows, and you will need a benchmark program. You will need something like Prime 95, ADA64, Cinebench. There's a number of them out there. Prime 95 is one of the more demanding ones, especially if you leave the ATX instruction set enabled on it. But I would use a combination of 2 or 3 of those different benchmarking programs to make sure that it's working in almost every scenario. And what you want to do is you want to run your overclock for like, I don't know, 20 minutes with those stress tests going to make sure that it's stable. If it crashes, if it blue screens, if it restarts your PC, if your screen splazzes out and stops working, then you know it's not stable. And what that means is you need to either increase the voltage or decrease the overclock. It's pretty much that simple. And while that's going, you want to keep a monitoring program like HW Infer or HW Monitor 64. You want to keep one of those monitoring programs on so you can take a look at how much voltage it's being given to the PC, at the temperatures, and at the frequency. That's the most important thing to make sure that everything is going correctly. Now, after that first test of the 20-ish minutes on the benchmarking program or stress test program, if that works, you can go back into the BIOS and bump up the overclock a little bit more. If you want to go further, bump up the overclock a bit more, eventually bump the voltage a bit more and test it again. If you are happy with how it is, and if you don't want to go any further with the overclock, you still go into the BIOS, and instead of bumping up the overclock, you bump down the voltage a little bit at a time. From, let's say, if you have 1.3, set it to 129 or 1295, and you slowly go bit by bit. You drop it by 0.05 or 0.01 anyway, and you go back into the system, boot it again, stress test it again, and make sure that it works okay. Once you are happy with whether you went for more overclock or for same overclock less voltage, when you are done fine-tuning it, what you want to do is you want to launch it and you want to run a stress test for several hours at least to make sure that it is stable. Now, also on the temperatures, to make sure that the temperatures are stable. Keep in mind, if you are using water cooler or an AIO cooler, that these take longer to actually saturate, because water has a very high saturation point. To make sure that your cooling is also stressed, you need to make it run for an extended amount of time so that the water actually gets to that temperature and that you get to test the cooling when the water is actually loaded with heat already. So keep that in mind, and that's why the 20-minute stress test is only a base to make sure that it's going okay, and that you actually still need to test it for several hours after that. Now, after testing for several hours, that should prove you that your overclock is mostly stable, and you should be good to go. Now, that does not mean that it will not crash in like 3 weeks from now, or that it will not give you a blue screen of death. For some reason. Uh, but yeah, it does mean that overclocking is kind of an ongoing thing and it's not a set and forget. But yeah, I mean, if you are meddling with overclocking, you probably are more of a tinker kind of person, and you are prepared for the eventuality that you might to adjust it every once in a while if it's giving you problems later down the road. So keep that in mind. And if something happens, oh yeah, maybe I should go set the overclocking down, or maybe I should set the voltage up. Keep that in mind as well. Now, what happens when overclocking goes wrong and you set the wrong settings? Now, you could fry your CPU, but that only happens if you set up a massive, massive voltage. If you go into the BIOS, remove all the power limits, because the power limits are there in the first place, so if you remove them, that's on you, really. And let's be honest, overclocking is not warranty covered. So make sure that you know what you're doing when you're overclocking and research properly, like I say. This video is not very in-depth, and I will be the first to admit I have not made things very clear in some points, but I'm winging it, and I'm not a massive expert either, just to get that out of the way. Anyway, the power limits are there. You will have to loosen the power limits a little bit when you are going to set your overclocking, but you have to limit them reasonably. Like I said, maximum of, to be safe, maximum of 1.4 volts, 1.45 at the very highest, and that's already playing with that degradation in the long run. So if you set out the power limits and you set there like, oh yeah, let's give it 3 volts, yeah, you might as well buy a new CPU immediately. Just order it before you do that because you're gonna fry it in an instant. Um, but yeah, if you do somehow uh, fry your CPU, you're on your own. But there are also other possibilities that things could go wrong, and that I mean, your hardware is fine, but the settings are not. And it might happen you cannot even load into the BIOS. Now, if you can load into the BIOS, I always advise to keep a default. There's a default button, and like every time you do a change to the default, and if you have a stable overclock and you tinker with it later, I would advise to save, because most BIOSes have a save profile kind of thing. So save your profile there so you can easily revert back to it if things go wrong. You can also save it on a USB flash stick. Most modern BIOSes support that to keep it safe and not to lose it. Now, what if things go completely haywire? Your hardware is fine because you did not overvolt it and you did not kill it, but it won't even load into the BIOS. What then? Now, some motherboards have a clear CMOS button. CMOS is basically what keeps your settings on your motherboard recorded while the PC is not powered. There's a small battery like that, like, a tiny like wristwatch battery kind of thing that is on your motherboard and that keeps it with a small power supply just to keep those settings there. Now, some motherboards have an actual button that clears the CMOS for you, so you don't have to actually do much other than press the button to clear it. And what that does, it resets your motherboard to default factory settings. Your profiles are gone, your settings are gone, but hey, it's working, so it's better than breaking it. Now, if your motherboard does not have a button like that, and bear with me because I will show you. Now, if your motherboard does not have a button like that, there you are. There is that wristwatch battery that I was talking about. Now, once you power off your PC, and you unplug everything, you unplug the power supply from everything, and you let it sit like that for a period of time. A period of time, I don't know, some people say 5 to 10 minutes is enough. You can play it safe and leave it completely unpowered for an hour. That means that whatever vestiges of electricity are on the system have bled off by that time and they are not there anymore and it's completely powered off. You take off that little battery and you wait, a few seconds, a minute or two, and then you put it back on. Now, what that does is that will basically cut off the power supply to the function that is keeping your settings there, and it will basically clear out all pre-recorded settings that you have included in your BIOS, and it will basically set it to default settings, and you are free to boot it back, put the battery back in, put your PC back together, and it should hopefully load without a problem, and you don't have to worry about that. You'll just have to, again, put all your settings in your BIOS again, and that's why you keep it on an USB drive, because you could have to do that. It does not happen very often. It could happen, and it's kind of a last resort kind of thing. If all else fails, then you probably have done settings very, very badly and you kind of probably might have killed your motherboard. But even then, there are other options like flashing the BIOS again. But yeah, you're kind of this is only in the very worst case scenario if you really mess with things that you don't understand and that you have not researched properly. And again, I cannot stress this enough. Do not take this video as an expert opinion. This is someone giving you information about what settings there are, uh, what you have to do in general, but do not take my values that I have given you and go and stuff it in your motherboard. Uh, do not hold me responsible for that because again, this is a very time-consuming process of trial and error. My settings worked out fine for me after hours of testing and stress testing and trying different settings. And I also had times when my BIOS was not loading and I had to reset it back to factory. Uh, not the CMOS, but I had to load a profile from a USB flash drive because the current profile was not booting properly. Although that was not really my fault of overclocking, that was a BIOS update directly from ASUS that was making my motherboard not boot. So that's actually not on me, that is on them. Anyway, with that disclaimer, do some good research. That's all I can tell you. I'm here to raise awareness and to give information on the topic. I'm not here to be basically a guide because I admit my video is not very much in depth on every point. I have not given full information on every setting that you need to change. It's not just going there, changing the power limit, the V-core, and the ratio and you're done. There are a few more settings that you need to do, but being my first time doing it, I kind of forgot. I kind of had a little sticky note in here and I will tell you which settings they are. But again, do not take my word for it, and do not go and shove those things there without proper research. So yeah, obviously you need to sync all cores and set a multiplier. There's something called multi-core enhancement that it is recommended here to disable, as well as something called SVID. Um, Also, load-like calibration, yes, I mentioned that. And CPU current capability, that is, it's power-related settings to your CPU, basically. So this is the ones that you need to be careful about. Now, CPU core and cache voltage, that's the one that I mentioned that you have to be careful about and not go too high, not over the 1.4-ish, like I said. Also CPU core and cache current limit, as well as the internal CPU power management, short and long duration power limits. Now, what you might see in some guides, and that's what I was actually reading from a guide now, because again, I'm not an expert, I don't know all these things by heart, and I am also in the process of learning. They might tell you to set the power limits to the max or to unlimited. This does not mean that your CPU will be drawing the max amount of power all the time. That only means that when it needs it, it will draw it. And it will draw as much as it needs at that point. So don't be afraid that it's going to fry out because of that. You can safely set those limits to the max when they tell you to. It's the core voltage or V-core that you need to be most careful about. That is the CPU killer right there. So take care of that. Anyway, this video turned out a bit more messy and a bit more improv than I expected. Sorry that it turned out so long. Sorry for the rambling and going off topic. It's just, like I said on my introduction video, if you have watched it, I am someone that is also learning about this, and I am just trying to share what I'm learning. So it might not be completely clear, and that might not be as well explained as some other YouTubers. I'm just trying to make it on a more accessible level for beginners and for people that want to know, whoa, what's that about, without actually going into all the technical details. So yeah, sorry if it's a bit disappointing in terms of actual juicy information, but I'm trying and I'm learning, not only IT, but I'm also trying and learning how to make better videos and give it in a more concise and explainable way to people that don't really know much on the topic. So yeah, bear with me and yeah. So good luck with your overclocking. Do your research once again, and I will see you next time.